All right, folks, so the show must go on. Here we go. The backup projector is up and running. So a little bit about our next planet here. And our next planet is Eris. There we go. So as mentioned the first time, Eris is the forgotten planet. You can go ahead and write down the information here about the mythology.
So how did you figure this out?
Figure like this stuff out?
Yeah. No.
Well, I forgot about it.
I wasn't paying attention when you did it.
Oh, this? I have a backup projector. This is what I used before I had a smart board. So, Greek goddess of strife and discord, that's what Eris is named after. Nice to see Eris is wearing clothes there. So, this is the best image. Listen up, guys. Sure.
Okay. I'm good then.
Okay. So this is the best image that we have of Eris right here. We have not gone there, and, you know, we really don't have too much else to go off of because it's a long ways away, further than Pluto is. So it looks even worse than Pluto did before we got there.
It's like present day, that's all we got.
Yeah, that's all we got.
Wait, isn't that what Pluto would be like?
Pretty much, yeah.
So then how do we know if it's actually white?
If it's actually what?
If it's actually white. Because Pluto looked exactly like that, and it wasn't.
Well, it's grayish white, Pluto is. So this is probably the same thing. You can kind of see gray around the edges there. So, again, listen up, guys. Keep it down, please. We haven't made it to Eris, so we do not know what its surface looks like. All we can do is make educated guesses, which is why this is going to be a pretty short lesson here. What we know is based on the Hubble telescope. And what we're guessing, and you can write down surface, we're guessing it's rocky and icy because that's what Pluto's like. And I like this picture a lot because you can really see, this is a good description of how small the sun would appear from that distance.
Would it be that bright?
It would still be that bright, yeah, yeah.
Is that Pluto?
No, this is an artistic rendition of what it would look like from Eris. What's that? No, that's Eris's moon, which we'll get to soon. The atmosphere is very thin. You can skip that.
How do they know that it's 2 pixels?
They said you need to see like the thick lines around that. How do they see
Right.
that?
So the thing is, when a planet goes from, like, whenever something crosses in front of a planet, the brightness decreases. Now, obviously, because it's not going to be lit for long. If that brightness is a sudden decrease, where it goes from there to not there, then you can probably guess that there's no atmosphere. But if it's a decrease that kind of goes down over time, even if it's a small amount of time, then that's probably because there's a little bit of an atmosphere in between the actual planet itself and outer space. And that's what we see when objects pass in front of Eris. There's that decrease over time. So we're guessing it has an atmosphere. We haven't seen it, but from this slide, go ahead and write down that it orbits the sun every 557 years. That was an excellent question on how we know it has an atmosphere. The second one. So Eris takes even longer to go around the sun than Pluto does. It's further out than Pluto and anything that we've looked at thus far in our exploration. 557 years. But it does spin 26 hours on its axis, so at least that would be sort of Earth-like. it would be considered, in my view, this would be the 10th planet. And it would be the end of our solar system with planets, if we went with my definition and with your definition that you came up with yesterday. Distance from the sun, the average distance is 67.7. That compares with Pluto's average distance of about 30 astronomical units. So it is out there a long, long ways. This shows the orbit of Eris around the sun. If you're looking down on it, you can see Pluto is right here, and Eris kind of takes this big oblong oval path. In addition to that, this is sort of interesting too. As Pluto goes around the sun, it does so at an angle, and Eris does so even more so. It is not in the same plane as the rest of our solar system. Another image right there that just shows it. So write this down, 18% the size of Earth. So it's a small world, but still quite sizable. Anybody tell me what country that is? Yes, Australia. Yes.
I thought you said everything was measured in radius.
It is, but, for this slideshow, I want to try and keep things in terms of what you're used to. That's why I put it in miles.
Well, really diameter. You have diameter. You said everything should be radius.
Yeah, scientifically speaking, like if we're talking like with astrophysicists, we put it in radius, we put it in kilometers. But because I want to keep things, more applicable to your lives, I try and put them in miles, and I think diameter is easier to visualize than radius. So that's just why I did it. In terms of the volume, well, that's off the screen. What you should write down here is that Eris fits into Earth 151 times. 151 times Eris will fit inside Earth.
100?
Yep. $151. Average density 2.52, so it's definitely a solid world that would not float on water. Write down the temperature. This is a cold, cold place. Even colder than the cafeteria. Guesses on nighttime temperature. Negative 36 what? 361, perhaps?
Negative 372.
Negative 372. Negative 400 is pretty close. Negative 406 is nighttime. You can write that down too. $40-degree difference between daytime and nighttime is actually kind of similar to Earth sometimes. Especially on those clear nights in the summer when it can get pretty cool after being, 80, 90 degrees during the day. Negative 406. So, Eris is... I don't think Eris is even on this picture. Yeah. So even if you could see it all the way down, you wouldn't see Eris. But it would be about half the size of that little dot. That's how small the sun would look. But still, we have to realize the sun would be bright. It's hard to imagine it being bright from that distance. But as far as the stars in the sky go, some of those stars are awfully bright. And they are way, way further away than the sun is to Eris. So the sun would be able to cast shadows, it would be bright, it would be able to give warmth. 40-degree difference between day and night from this distance is actually not too bad. So yeah, we can only see Eris at nighttime because there's no way you'll see something that small during the day. It's way too faint to see even on the clearest, darkest nights. But if you do have a telescope that's a decent size like the one in the back, this is the sort of thing that you'll see. These would just be the surrounding stars, and you'd see this little thing moving. That would be Eris right there. Eris was found pretty much the same way Pluto was found, except they used computers, so it was much easier to see dots moving with respect to the stars than it was for Clyde Tombaugh in the early part of the 1900s. So that's Eris right there. But if you look at it through the Hubble, you're able to see it a little bit better than that speck we saw before. This is the best image that we do have of Eris. And of course, you can see right next to it, there's another little dot, and that's going to be its moon Dysnomia, which we're going to cover shortly. Write this down. During the day, it is blue. That is their guess based on what we found on Pluto. After all, Eris is roughly the same size as Pluto, and it's probably got an atmosphere, so the sky is going to look roughly the same is probably what we'd find. So blue skies, Mr. Blue Sky. Gravity. We've got 8.4% of Earth's gravity here. So just like Pluto, you would be able to leap a long, long ways in the air. One of the neat activities we eventually do in this class, we find out exactly how high you could jump on all these other planets. So look forward to that in a little while. In terms of your jump height, roughly 12 times your jump height on Earth. You can write that one down. This is their best guess as to the geological activity on Eris. Probably. My guess is that this is wrong, because this is what they expected with Pluto, and it was absolutely wrong. Pluto is a vibrant, crazy, interesting world. Eris would probably be the exact same thing. So you don't have to write this down. Nobody knows for sure. But they're guessing it's a cold, dead world, just like they erroneously guessed Pluto would be. And these are their guesses as to what it's made up of. You don't need to write these down because we don't know for sure. But yeah, frozen methane and nitrogen, that's kind of what makes up Pluto's crust, so they assume that's the sort of thing that will happen on Eris.
So why would they think it's that?
I don't know. Because it's so... I think they're guessing that Pluto is an anomaly. Because, again, we're assuming that the universe is billions of years old, along with all these other planets. So you'd think that Pluto ought to be dead, but it's not. So my guess is they're just thinking Pluto is an anomaly to that, and that Eris would be more normal, and it will be a cold, dead world.
Is that one of the reasons why they don't consider it a planet?
No, it's not. They don't consider Pluto a planet or Eris because they exist in the Kuiper Belt. And there's things in the Kuiper Belt, so they say it has not cleared the path around its orbit. And that's why they disqualify it as a planet. Seems kind of lame to me, but it is what it is.
Doesn't Pluto cross in front of another orbit?
It does. It does cross in front of Neptune. So for a period of time, it is inside the Kuiper Belt. But there's still those objects in the rest of Pluto's orbit. And that's what they say disqualifies it. So, yeah, absolutely. It's also predicted to have a small magnetic field. It probably has some ice, just like Pluto does. Remember, Pluto has those mountains made up of ice. That would be really interesting to see and slide down. They think there might be more under the surface. No one really knows. Whatever. But, just like on Pluto, if you land there without a spacesuit, you'll be frozen solid. If you land there with a spacesuit, it's just a matter of time until things inside that suit start to freeze up on you. So you'd be frozen solid eventually on this world. And again, this is not an actual picture of Eris. But it's just an artistic representation of what they think it might look like. And chances are it is far off, and chances are it's a lot more interesting to see than what they're guessing, just like on Pluto. So that's the end of Eris. Now we got to do its moon. And you can probably guess.
I was about to say, we only wrote 10 things down in our quiz.
Yeah.
Are there any plans to go to Eris?
Are there any what about Eris?
Like plans to launch a probe to Eris?
No, there aren't, which makes me sad. If they considered Eris a planet like I do, then they would. But they just think of it as a dwarf planet, not unlike a lot of those rocky bodies out there. And so, yeah.
Maybe they just don't want to be wrong again.
Maybe. You can go ahead and keep it down for a little bit. Write down Moon of Eris, that's Dysnomia. It also bears mentioning from Eris, it was discovered in 2006. You don't have to write that down, but it is a very recent discovery compared with the other planets. Yes. And again, this is an artistic representation. We don't know what Eris's moon Dysnomia looks like, but it's kind of a neat little mysterious image there for you. You can write this down. We do know for sure that it's named after the daughter of Eris, the goddess of lawlessness. I could not find an image of that Greek god on the internet, so I just put Eris back up there. Looks like she's having a blast. Some sort of dance move there. I wonder if they forgot the R. There we go. So yeah, Dysnomia is the daughter of Eris, the goddess of lawlessness. And like I said before, this is the best picture we have of Dysnomia. This is the moon of Eris right there. Yep. And it goes around Eris, because that's what moons do. You can write down its size. Based on the few pixels we've been able to see, we know it's roughly 260 miles across. So it would fit inside Wisconsin. Dysnomia is this little one here. Yeah. Yeah. I guess I'm not aware of any that do, but yeah, they could.
What if Earth, yeah, sorry, what if we have more, like, what if we had, like, 8 moons?
Well, I think we sort of do. We have the regular one, and then there's one that's like 200 feet across or something that we don't really talk about too much.
Well, like,
I
what
think
if we had, like,
Yeah.
what happened? Like, what if we had as many as, like,
Well, if they were all just the size of little rocks like that, we wouldn't really notice, but if they were the size of the moon or something like that, you would really notice, and the oceans would notice, because the tides would be really, really messed up. And so would all the ocean currents. It would be crazy.
Very cool.
Yeah.
So I just seen, like, 25 moons.
So we've got these. These are some of the smaller, but still very large objects in our solar system. Ceres is only 600 miles across. Pluto and Eris are much, much larger. And from my planet definition and yours, these would be considered planets. Eris would be outside that definition because it wouldn't be big enough. There are other objects out there, things called, I think one is called Sedna, and a couple others, but they too would be smaller than a radius of 1,000 kilometers, so they also would not be planets. You can skip this one. We don't know very much at all about Dysnomia. about its surface, about its whether or not it would have a small atmosphere or anything like that. We know that we cannot see it from Earth unless we have an enormous telescope, and if we have an enormous Earth-based telescope, this is the sort of image that you'll see. That's the best image of Dysnomia there that we've gotten from Earth. The best images that we do have are from the Hubble, because the Hubble doesn't have to look through the Earth's atmosphere, and that's where we get this image from that you've seen from earlier. Yeah, that's it. So yeah. Yes, we will. I actually have it queued up. Quiz on Eris and Dysnomia tomorrow. Yep.